The enthalpy change of a neutralization of hydrochloric acid may be determined by using the apparatus. So how much energy change occur when acid is neutralized by an alkali? Polystyrene cup is there, reaction mixture of acid, HCl and sodium hydroxide, and recorded the temperature change. First, the procedure, what we did, we took 25 cm cube of concentration 1 mole per dm cube hydrochloric acid in a polystyrene cup. We record this initial temperature, then we record the temperature of 30 cm cube of 1 mole per dm cube sodium hydroxide, and then we add sodium hydroxide to hydrochloric acid, stir the mixture, and record the maximum temperature reached. Give a reason why an excess of sodium hydroxide is used. So why we use more than enough? Because we are finding how much energy change occur when acid is neutralized. So if acid is neutralized, so it means we have to neutralize all of the acid, as we are finding the enthalpy change of neutralization of acid. So why excess of sodium hydroxide is used? Just to make sure that all of the acid is neutralized. So if we make sure that all of the acid neutralized, then we can work out how much acid, like how much energy is given off, and using that E is equals to Cm delta T, we can find the enthalpy change. The diagram shows a part of a thermometer when thermometer reach the maximum value. So what is the temperature reading here? As you can see, record the temperature in the table of result and then complete the table by giving a formula. So what is this number? So this is 25, 26, 27, 28. So it is between 27 and 28. So it will be 27.5. So here the maximum temperature rise here, what we'll write 27.5. The temperature change means the difference in the temperature. So maximum from the starting, when we take a difference, so it will come out as 6 degrees. So 6 degrees is the change in temperature. Then calculate the enthalpy change of neutralization. Assume that the density of both solution and the mixture is 1 gram and the specific heat capacity. So we have the formula E is equals to Cm delta T. Where C is a specific heat, which is 4.2. But what about the mass? Mass is actually a volume of a solution is equals to mass. And if you see in the beginning how much acid was mixed with an alkali, so 25 cm cube of acid mixed with 30 cm cube of alkali. So what is the total volume? The total volume will be 55. If total volume is 55, the total mass will also be 55, because we mix them together. Like we were having 25 cm cube of acid, we were having 30 cm cube of alkali. We add, so the total solution will turn into 55 cm cube, and we assume that the density is 1 gram per centimeter cube. So the mass of the solution will be 25, like there is 25 gram of water. So that's why we write not 25, 55 gram of water. That's why we write 55 here. And then delta T, the change in temperature when we mix the two solutions with each other. The change in temperature was 6. So this, when we multiply these factors, this will give us how much energy change occur. But we need enthalpy change after getting the energy. Like when we multiply this, the energy will be 1386 joules. But we need enthalpy change. Enthalpy change is energy per mole. So how many moles of hydrochloric acid are used? That is concentration into volume. So moles equal concentration into volume. Concentration in the beginning, we use 1 mole per dm cube. That was concentration. And volume was 25 cm cube, but that should be in dm cube. So the concentration will be 0.025. that is not concentration, moles, because mole is concentration into volume. Concentration of a solution is 1 and the volume is 25 divided by 1000, so it is 0.025 moles. Now we need enthalpy change per mole. So because what happened, 1386, that is in joule, but enthalpy change, the SI unit is kilojoule per mole. So we have to convert this into kilojoule, divide by 1000, so it will come out as 1.3. So this will be 1.38 kilojoule divided by the number of the moles, 0.025 mole. So when we divide this, we'll get 55.4 kilojoule per mole. But as you can see in the beginning, the temperature was 22.5 and then the temperature rises to 27.5. So if the temperature of a mixture rises, it means the reaction is exothermic. So we have to add a negative sign at the last to show that this reaction is exothermic. If you only write 55.4, then you will lose 1 mark. Out of 4, you will score 3. Is it clear, this question, that how we work out the energy change when acid is mixed with an alkali? Then the experiment was repeated using a glass beaker instead of polystyrene cup. Explain how the value obtained for enthalpy change of neutralization would be different. So because polystyrene is an insulator means it does not allow heat to escape. But whereas glass is there, it can allow heat energy to escape. So the temperature change will be, glass is relatively better conductor. So glass will remove the heat energy from the mixture, from the solution. So the temperature change will be smaller. If temperature change is smaller, because in a polystyrene cup we have a container like a polystyrene cup, the solution is there inside the polystyrene cup. When the solution, the reaction occur between acid and alkali, it is releasing a heat energy. But polystyrene is insulator, so the thermometer shows a greater change in temperature, about 6 degrees. If we use a glass beaker, glass can conduct heat energy. So that heat energy from the solution will transfer out to the surrounding. As a result, what will happen if this heat energy escape, the temperature change when this reaction occur will be smaller. If temperature change is smaller, like example 4 degrees there, so if we have the formula E is equals to Cm delta T, temperature change is smaller, so energy which we calculate will come out smaller, and enthalpy change is energy per mole. So if energies which we calculate is smaller, the enthalpy change will be less, like smaller value, or it will be less exothermic. Is it clear? Like what will be the effect of using the glass container for this enthalpy change of neutralization as compared to polystyrene?